Welcome to your third video in the second half of Chapter 4. This particular lesson deals with the inverse trig function. So we spent a lesson graphing sine and cosine. We spent a lesson graphing tangent, cotangent, secant, cosecant. This one graphs the inverse trig functions. And I'd like you to remember that inverses are one-to-one, and they must pass a horizontal line test. Therefore, if you look at the sine function, go ahead and graph that in on your paper. If I try to do the horizontal line test here on this graph, it would fail. And therefore, we have to restrict the trig functions in order to get an inverse. We're only going to look at part of the graph. Now, when we look at the part of the sine graph, we are going to look at it from here at negative pi over 2 to positive pi over 2. We're going to look at this little sliver right there. And when we take that sliver and we get the inverse of that, if we want to get the inverse, right, we switch the x and the y. So now instead of y equals sine x, I would have x equals sine y. And if I want the inverse, I'm going to flip my x and my y. Let's go back and look at the graph here. If I've got 1s on my y-axis, I'm now going to have 1s on my x-axis. Negative 1 and 1. And now my radian values would be going on the y-axis. So here I'm going to do pi. That goes to pi. That will be pi over 2. There we go. So here at 0, I'm still at 0. But instead of being at negative pi over 2, negative 1, I'm going to be at negative 1, negative pi over 2. Right? It flipped. And here, instead of being at pi over 2, 1, I'm going to be at 1 pi over 2. So the graph shifts like this. And let's look at the domain and the range. We are now going to restrict our domain to go, and it includes negative pi over 2 to pi over 2. And my range then is still from negative 1 to 1. And it includes those values. But look at what happens when we inverted those. The domain now is from negative 1 to 1. And my range is from the negative pi over 2 to the positive pi over 2. Remember when we did inverses before, the x and the y changes, and the domain and the range swapped too. So you can see those are swapping if we did it correctly, and we have the inverse. So we can denote this by saying that the y, this graph right here, y equals the inverse sine of x. We also denote that with arc sine. You'll see it both ways. You'll see sine negative to the negative 1, the inverse sine, or you'll see arc sine. So I need you to remember, and your author goes back and forth as well. I need you to remember that those are interchangeable. And the way you would find that is, and we did this earlier when we were trying to find the angle, we did the inverse on the calculator. But now, if I give the value, now that you know your unit circle, you don't have to use the calculator, and we don't want you to, as a matter of fact. But the angle whose sine is that value. And if our domain and our range now, we are only playing between negative pi over 2 and positive pi over 2. So all of our values will either be in this positive quadrant or they'll be in the negative, like a positive 30 degrees or negative 30 degrees. Positive pi over 6 or negative pi over 6. They will fall within those two quadrants, so to speak. Now let's look at the cosine graph. I'd like you to go ahead and graph the normal cosine graph and the normal tangent graph on these graphs. And let's go ahead and write in the domain and the range. Here, our domain, we have to restrict it. We have to get a little sliver. And for the cosine, we are going to go from 0 to pi. So we are going to restrict it in that range. That is pi. Let me write that in. So we have our domain from 0 to pi, and it includes both of those. Our range is still from -1 to 1. Let's look at the tangent real quick while we're doing this. Our domain here, our x values, can be anything, right? Let's look at just this one right here. It's not at the pi over 2's, right? Because they're asymptotes. So for this sliver, we are just going to take this piece, that one period right there. Because the horizontal line test passes for that piece, so we can do that whole piece of the graph. But the domain cannot equal the -pi over 2 and pi over 2. So we have parentheses there because of the asymptotes. And then the range could be any real number. So we're going to say -infinity to infinity. Now let's go back and invert those. So if I want the inverse, I'm going to flip the x and the y, and I'm going to make this graph. Here I have my 1's and my -1, and then my radian values are now on my y-axis, and that would go to pi, and this would go to -pi. And so now where I was at 0, 1, I'm going to be at 1, 0. Here where I was at pi over 2, 0, I'm going to be at 0 pi over 2. Here I was at pi, -1, so I will invert that, I'll be at -1 pi. I'm up here. So it has flipped. Remember the inverse also, you can draw the graph. If I put both of these on the same graph, remember we can draw the y equals x, right? And it would flip both of those. So if I were to extend that and draw that line through there, it's easier to see if I draw it through that one, how it's the same line. Kind of hard to see on this one, but I would need to extend it. Here, let's look at the domain and the range. The domain for this graph is between -1 and 1, and it includes them for the cosine. The range goes from 0 to pi. So these have been flipped. Let's look at the inverse tangent graph. The inverse tangent graph is going to have asymptotes. Let's see, this would be at 1, that would be at -1, so I'm going to still have my 1 and my -1. But here I have my radian values, pi over 2, -pi over 2. So my asymptotes now are horizontal. My graph, 0, 0, still the same. But the graph now, remember at pi over 4, the graph is at 1. And at -pi over 4, the graph was at -1. My graph is a little off. This should be over here. Right? So we can graph this if at so at pi over 4, it was at 1, so now at 1, it's going to be at pi over 4. And at -1, it will be negative pi over 4. So you have this going on right here. Okay? Let's graph that. Now let's talk about what that means in terms of the domain. The domain here, your x values, once you have the inverse for the tangent, they can be anything, right? but the range values are now restricted between the pi, and it can't equal, so you have parentheses, negative pi over 2 and pi over 2. Let me write this in. This is also going to the inverse. Okay, don't forget that all of these are interchangeable, and you're looking for the angle that has a tangent of x, or the angle who has a cosine of x, whatever value that is. You'll see this when we start doing some examples. All right. I'd like you to remember an important differentiation. For example, I picked cosecant. Cosecant is equal to 1 over sine x. And we can rewrite that. Remember, if you have a value in the denominator, you can put the whole value to negative 1. That's different than what we've been doing with the inverse. Okay, this just means reciprocal. This is the reciprocal of the entire function. So when you graph cosecant, or when you are evaluating a cosecant, you would put 1 over the sine of the value. But when you have the sine to the negative 1 like this of x, that's the arc sine x, that's the inverse. That's what we're talking about in this lesson. And it's very important because there is a command on the calculator that does this. This is giving you the angle where sine is x. This is giving you 1 over sine x, or the cosecant of the angle. They do two very, very different things, and I need you to be able to differentiate and not get those confused. Let's talk a little bit about the inverse. Do you remember when we used this to find the angle? If I gave you a triangle and I said your opposite side was 3 and the hypotenuse is 7, what is theta? Then you looked at that and you said, oh, that's a sine, because that's opposite over hypotenuse. So I would take the sine of theta, and that would equal 3 over 7. And then I said, find theta. So that was your problem right there. And I said, find theta. Well, then you did the inverse of sine. You said theta was equal to the inverse of sine, 3/7. And we got, if you were in the correct mode, degree mode, you could have told me it was 25.38 degrees. We did this in the last unit. So you have used the inverse, you just haven't graphed it, and that's why I want you to do that. Now, because of your new knowledge of the unit circle, you can now get a lot of these values without using the calculator, and the numbers will be nicer. And let's do some examples. We're going to evaluate using these, using the unit circle. So my first example is, if I want you to evaluate sine, the inverse sine of 1/2, tell me where that is. What is that equal to? That is asking you is, what is the angle whose sine is 1/2? Now you need to remember that on your the inverses, remember, for the sine are only valid here in those two quadrants. So where in those quadrants 1 and 4 is sine 1/2? And sine 1/2 would be right here at the pi over 6 value. So let's write that in. That happens at pi over 6. So that's my answer. Now I'm going to get you let you look at another example here. I did have sine and I changed it to cosine, so we could do both. The inverse cosine at -2 pi wants to know the angle whose cosine is at -2 pi. Well, I realize I forgot to show you something on the notes. Let's go back to this real quick. Here, the cosine value is only valid here from 0 to pi. So that's here in quadrants 1 and 2. Now tangent is similar to sine because it is valid on the pi over 2 to negative pi over 2. So